morning. Today we are going to start the topic trigonometric or polar form of a complex number. Trigonometric or polar form of a complex number. This is exercise 21D of S.Chand. First of all, we'll try to understand that what is the trigonometric or the polar form of a complex number, right? Suppose if the complex number z is equal to x plus yi. If this is the complex number, then the polar form of a complex number or the trigonometric form of a complex number can be written as r times cos theta plus I sin theta. This is called as the polar form of a complex number. Clear? Now we will try to understand this polar form of a complex number because we will be asked to write the complex number in the form of a polar form or in the form of a trigonometric form of a complex number. Right? Is the question clear? The question I said is, if you will be asked to write down the polar form of a complex number. Clear? Polar form of a complex number. So we will be given the complex number, and then for that complex number we have to write that in the form of a polar form. Is it understood? So the polar form of a complex number can be written as r times cos theta plus I sin theta. Clear? Now let us try to understand this polar form first of all. In this polar form we have two components. This is one of the component which we call as modulus. Right? And this is called as, this theta is called as amplitude, or we also call this as argument. Am I very clear? Now, R is the modulus and theta is the amplitude or the argument. We already know in the previous exercise we have learned how to find the modulus of a complex number. So this modulus of a complex number we can calculate by using the formula R is equal to root over x square plus y square, because our complex number is z is equal to x plus yi. So this is how we will calculate the modulus of a complex number. Now amplitude, this amplitude is theta is equal to tan inverse y over x. This is the formula we can use for finding the amplitude or the argument. Hope this is clear. So once these two are calculated, whenever we are asked to write the polar form of a complex number, our aim will be to calculate the modulus and then the amplitude or the argument. And after calculating these two components, we can just punch it in the formula and have the polar form of a complex number. Hope I made it very clear. Once again I am repeating, polar form of a complex number is r times cos theta plus I sin theta. This is read as polar form of a complex number, right? So if our complex number is z, then we can have the polar form of this complex number, right? We can have the polar form of any complex number, and the format of the polar form of complex number is r times cos theta plus I sin theta. Is it understood? Now to complete the polar form of a complex number, we need to have the value of the r, which is modulus, and then we can have the value of theta, that is called as the amplitude or the argument. So by calculating these two components and putting it in this given formula, we are able to get the polar form of a complex number. Is it okay? So this amplitude is not an issue for any one of us because we have already seen this in the previous exercise. Now we need to understand a little bit this amplitude, right? How do we calculate the amplitude? Is it okay? No, it is not simply as you see in the formula. Theta is equal to tan inverse y over x, right? Is not just the amplitude. Of course, this is amplitude, but this is not the complete information about the amplitude or the argument. Is it okay? We need to know that what is the location of the angle theta. What is the location of the angle theta? So by knowing that only we will be able to get the exact value, the correct value of the amplitude, and then we can have the correct polar form of a complex number. So I'm going to just give you some little information, some technique to get the actual value of theta. Is it okay? So to do this, let us have the coordinate first of all. Let us try to understand the coordinate. This is the coordinate, right? This is the coordinate, right? This is the x-axis and this is the y-axis, or we can say this is the axis for the real number, for the real value of x, and this is for the imaginary part. The imaginary part can be plotted along y-axis. Is this very clear? You know that in the coordinate, this is the first quadrant, this is the second quadrant, and this is third quadrant, this is fourth quadrant. Clear? Now here we are going to use it for finding the exact value of amplitude or the argument. Is it okay? Now to calculate the amplitude or the argument, first of all we calculate the acute angle. We will calculate the acute angle. We cannot get the direct value of theta. Please be mindful. Listen me very carefully. What I am saying is, in order, amplitude is theta is equal to tan inverse y over x. But this amplitude cannot be calculated directly. Okay? This amplitude can be calculated by finding the acute angle made by the complex number. Again I am repeating, this theta can be actually calculated by finding the acute angle made by the complex number. Is it okay? So that is what we are trying to understand. Now that acute angle we can assume it as equal to alpha. This acute angle is alpha. Suppose this is the acute angle made by the complex number, right? And it is denoted by alpha. Only after calculating alpha we can get the value of theta. Again I am repeating, this is the acute angle made by a complex number. Clear? So only by calculating this we will be able to get the value of amplitude or the argument. Is it okay? So there is a technique, there is a formula. Now suppose if this acute angle lies in the first quadrant, if your acute angle or suppose if your complex number lies in the first quadrant, is it okay? If the complex number lies in the first quadrant, right, then this argument, after finding the value of alpha, this argument can be calculated by using the formula theta is equal to alpha. Theta is equal to alpha if your complex number lies in the first quadrant. I will teach you the technique to know that what is the location of the complex number, right? So just have patience and then go to the next. Now if you find that your alpha, this complex number lies in the second quadrant, right, lies in the second quadrant, then this amplitude, that is theta, can be calculated by using the formula pi minus alpha. And that is why I told you that amplitude theta cannot be directly calculated. We can find out the amplitude by first finding the acute angle made by the complex number. Is it okay? So we are calculating first of all alpha, and then we can find from this complex number we will know that what is the location of your complex number, and then we can use the appropriate formula and get the amplitude. Now if your complex number lies in the third quadrant, then theta will be equal to alpha minus pi. And likewise, if your complex number lies in the fourth quadrant, then your amplitude will be equal to, theta will be equal to minus alpha. So for finding the amplitude, please take a note of this, and this. Is it okay? So with this only we will be able to get the actual amplitude. Alright. So after this, now we are going to take some questions. Thank you. Now we are taking the first question of this exercise, and here we have to find out the modulus, amplitude, and then the polar form of this given complex number. Again I am repeating, for this question we are going to calculate the modulus, the amplitude or argument, and also we are going to write the polar form of this given complex number. So there are three things we are going to calculate, right? The main is the polar form. Main is the polar form, because for writing the polar form of a complex number, obviously we have to calculate the amplitude and also we have to calculate the modulus. Is it okay? So we will focus on the polar form, right? So first of all, to write the polar form of this, the most important thing is that we have to know that what is the location of this complex number, right? So to know that, we will draw the coordinate. This is the first thing for every complex number. Whenever we are asked to write the polar form of a complex number, whenever we are asked to write the polar form of a complex number, this is the first thing that we will always do. By doing so, we are able to find out the exact location of the complex number. And once we know the exact location of a complex number, then finding the amplitude will become very easy, right? So let us do that. Now, this is complex number, this is the real part and this is the imaginary part, right? So the coefficient of I will be also a real number, and this value will be plotted along the x-axis, this real number part, and the imaginary part will be plotted along the y-axis. So we are now going to plot it. This is root 3. Root 3 will be somewhere here, right? Root 3 will be on the x-axis. It is positive, so it will be on the right side of x-axis. Okay, on the x-axis. So this is somewhere here. And then I coefficient is 1. That means it will be somehow up. Is it okay? Now with this we got the location of the complex number. This is the coordinate of complex number. Is it okay? Now we can join it with the origin. Clear? So this is your angle made by the complex number with the x-axis, and this is that acute angle. This is that acute angle. As I told you that the amplitude theta cannot be directly calculated. We can, for finding the amplitude, right, we will always find out the acute angle alpha. By finding the acute angle only, we will get the value of theta. Is it okay? So now we know the location of this one is first quadrant. This is first quadrant, and then you know that in first quadrant, what is the relation between theta and alpha, right? So let us find out first of all now the modulus r, which is equal to, root over x square plus y square. X square means root 3 square. Root 3 square plus y square. Coefficient of I is 1. So 1 is square. This is giving you your modulus. Now square and square will cancel. So this will become simply 3. This is simply 1. So 3 plus 1 is 4. And root over 4. This is root over 4. Finally, when you simplify, this comes as equal to 2. So for this complex number, the modulus we calculated is equal to 2. Now we are going to calculate the acute angle first of all. Acute angle, right? Only after calculating acute angle, we will then calculate the amplitude. Acute angle. This is acute angle. This is tan inverse of y over x, right? Y over x. Now this is tan inverse. Y is the coefficient of I, that is 1. And then x is this value. This is root 3, right? So for what angle, at what angle the tan, for what angle the tan value is equal to 1 over root 3? For what angle of tan the value is 1 over root 3? Are you getting it? So we know that it is at 30 degree. At 30 degree. So that 30 degree in radian, we can write it as pi over 6. 30 degree. Pi value is equal to 180. So 180 divided by 6 will be equal to 30 degree. So we got the acute angle as equal to pi by 6. With the help of this, now we are going to find out the amplitude. And since the complex number is lying in the first quadrant, so the relation between theta and pi is that theta is equal to pi. I showed you the diagram, right? So from the diagram we know this relation. So theta is equal to alpha, and therefore your alpha is calculated is equal to pi over 6. So this is equal to pi over 6, right? Now finally we got this modulus, we got the amplitude, we can write the polar form of a complex number. So polar form of complex number, polar form of the complex number can be given as, formula is r sin theta, r cos theta. R is how much? 2. This is 2, and then cos theta, cos, and theta we calculated pi over 6 plus I, and sin theta, sin pi over 6. This is your answer. Is it okay? So we calculated all the three things. Now let us take one more question, that is question number 3. We are taking question number 3 on the same question number 3. This question number 3 is complex number is z is equal to -2 plus 2 root 3i. This is our complex number. Now for this question also, for this complex number also, we have to find out the modulus, the amplitude, and the polar form of a complex number. Clear? So we will first of all, for finding any of these three things, we will first of all, before that, we will find out what is the location of this complex number. Where does it lie? Is it okay? So that we will be able to get the correct value of amplitude, that is theta. So let us draw the coordinate once again. I told you to find out the location for finding the amplitude. This is very important, right? Now let us plot this complex number. This is x is equal to -2. That means it will be on the left side of the origin, right? On the x-axis. So somewhere this will be -2, right? And this is 2 root 3. This will be positive. So it will go above the origin. That means this is the location of your complex number. This is somewhere here. Am I right? Now let us join this with the origin. Clear? So now this is your theta, right? Now from here we understood now this theta, this complex number, it lies in the second quadrant. It lies in the second quadrant. So now we will keep that in mind and then we will take care. Now we are going to start first of all with the modulus. R is equal to modulus, that is -2 square plus 2 root 3 square and then root over. This is -2 square means 4. This is 4 and this is into 3. This is equal to 4 3 is 12 plus 4 16 root over 16 and the square root of 16 is 4. So this is the modulus of our complex number. Now we are going to find out the acute angle. First of all, I told you that theta cannot be calculated directly. We need to find out the acute angle first of all, and that acute angle we are denoting by alpha. So we are going to calculate the alpha by using the same formula, tan inverse, right, y over x. This is tan inverse y. Y comes to y is 2 root 3. 2 root 3 and then divided by -2. Clear? So this 2 is cancelled. Your answer is coming minus root 3, right? So just go for magnitude. Okay, just go for magnitude. Either by using the table or by using the calculator, we can get the value of alpha. For what angle of 10? For what angle of 10? The value comes as equal to root 3, right? Obviously, the value, the angle will be 60 degree, and that 60 degree, if we write in radian, we can write this as pi over 3. So we got this acute angle, right? Acute angle. Pi over 3 means 180 divided by 3 is equal to 60. So this is acute angle. Now, you know that the complex number lies in the second quadrant. Lies in the second quadrant. So when it lies in the second quadrant, then the theta is equal to pi minus alpha. Theta is pi minus alpha. So let us calculate the amplitude now. This is pi as it is, and minus alpha. Alpha we calculate pi over 3. So pi over 3. Now when we calculate 3 pi and minus 1, so it's equal to 2 pi over 3. This is actually the amplitude. Please make it, understand it very well. This is not the amplitude. Amplitude is this. For finding the amplitude, we are calculating the acute angle made by the complex number, and after finding the acute angle, we then find out the amplitude. Right? You can cross check these two questions. You will understand every time we are doing the same thing. We are calculating first of all the acute angle, then we are calculating the amplitude. We are using different formula depending on the location of your complex number. And now finally we can write the polar form. Polar form. Polar form. This polar form formula is R. R is going to be 4. This is 4 times cos theta. Cos of theta. Theta is how much? 2 pi by 3. 2 pi by 3 plus I sin theta. Again theta is 2 pi by 3. 2 pi by 3. This is the polar form of your this given complex number. Hope you have understood and got the basic idea of how to write the polar form of a complex number. We'll continue with some few more questions. Thank you. Let's take some few more questions. Question number 5. This question of 5 again, we'll find out the polar form, we'll find the amplitude, we'll find the modulus, everything we'll find out. So as I told you that the important thing is the polar form, because once we calculate the polar form, then the other two things, the amplitude and then the modulus, both will be automatically included. So we are going to find out the polar form. But now for finding the polar form, as I told you, the first thing that we will do is we will find out the location of the complex number. So draw this coordinate, right? Draw this coordinate. Now let's plot it. This is x coordinate is -1. So -1 will be somewhere here, right? And y also is -1. That means it will be below this. That means the point will be here. So when we join it with the origin, we can see that this line represents your complex number and it lies in the third quadrant. It lies in the third quadrant. Is it okay? So now we are going to find it out. First of all, we are finding the modulus. Modulus r is equal to root over -1 square plus -1 square root over -1 square means 1, -1 square is again 1, root over this 1 plus 1 is equal to root 2, and this cannot be simplified anymore. This is the modulus of your given complex number. Now we are going to first of all find out the acute angle. Acute angle. So acute angle is alpha. Alpha is equal to tan inverse y over a. Y is coefficient of I, that is -1. Then x, the coefficient of simply the real number, that is -1. So minus is cancelled. This is 1. So this is equal to tan inverse 1. Now you know at what angle of 10 the value is equal to 1. For what value of 10 the value is equal to 1. For what angle of 10 the value is 1. It is 45. We know it is 45. So therefore the angle will come as equal to 45. This 45, if we write in the radian, it will become pi over 4. This is pi over 4. So after this is calculated, now we can find out the amplitude theta, because this in complex number it lies in the third quadrant, and in the third quadrant the relation is alpha minus pi. Alpha minus pi. So let us find the value. Alpha is pi over 4 minus pi. Is it okay? Pi over 4 minus pi. Now when we calculate, this comes as equal to -3. It comes as equal to -3 pi over 4. I don't need to tell you that how do we simplify this two number. This is fractional number. This also will be considered as fractional number. Then by finding the LCM and then simplifying, we get the result. And so therefore this is your amplitude. Now once the amplitude is calculated, the modulus is calculated, we can write down the polar form of a given complex number. Therefore the polar form of the complex number will be equal to r. R is equal to root 2 times cos theta, that is cos of negative 3 pi over 4 plus I sine negative 3 pi over 4. This is the polar form of our given complex number. This is the answer. Is it very clear? Let us take one more question, that is question number 8. We'll take one more question, question number 8. Question number 8. Here the complex number we have is, complex number that is given is equal to simply -2. Now this is a complex number. Look here. Here this is complex number. Now you compare this complex number with your previous complex number or with any other complex number. What you will notice is, here we have only the real part and imaginary part is missing. What does it mean? It means the coefficient of that I is 0. Clear? That means if we rewrite this, modify, we can write this complex number as -2 plus 0i. This is your actual complex number. This is because coefficient of I is 0. That is why this part gets deleted and it was only -2. So for our understanding, we wrote it in the actual form, in the form of complex number, having the real part as well as the imaginary part. Is it okay? Now what we are going to do is, first of all, we are going to find out the location of this complex number. So once again, let us draw this complex number, right? This complex number, and now plot it. This is x negative 2, this is somewhere here, and then y is 0, that means this point will remain here only. So this you can join with the origin, so this is your complex number. That means your complex number lies on the x coordinate itself. Is it okay? So it will be taken in the second quadrant because it is lying on the line at 180-degree angle. Therefore, this will be taken in the second quadrant. Is it okay? And in the second quadrant, we need to know that how do we calculate the theta. So in the second quadrant, theta used to be pi minus alpha. Pi minus alpha. Clear? So keeping this in mind, we are going to calculate first of all the modulus. Modulus is negative 2 square plus 0 square. This negative 2 square will become 4. 0 square means 0. And therefore the modulus will become 2. Now we are going to calculate the acute angle alpha. Alpha is equal to tan inverse negative y. Y is 0. Coefficient of I. And then x is negative 2. So 0 divided by any number will be 0. So tan inverse 0. Now tan at what degree? The value is equal to 0. Obviously tan at 0 degree only is equal to 0. Therefore alpha is equal to 0. Is it okay? So from here now we can calculate the value of theta, that is the amplitude, or we can also call this as, this theta is called as amplitude as well as the argument, right? Now this theta we can calculate by using the formula pi minus 0 is equal to pi. So now finally we can have again the polar form of a complex number. We can write as r is 2 times cos theta means pi plus I sine pi. This is your answer. Let's take one more question. This is question number 9. I think with this many number of questions, your doubts about the polar form of a complex number will be completely clear, right? Hopefully. Now this is a complex number and we have to again find out the polar form of this complex number, right? Now as you can see, this complex number is really complex. No, this complex number is really complex because it's not very simple. It's not in the modified form. So first of all, we will simplify this complex number and we can have it in the appropriate form, in the only form of x plus yi, okay? And then we will change that into polar form. So first of all, this question needs a rationalization. Why I'm using the term rationalization is because you can see there is complex number even in the denominator, which is not acceptable, right? Complex number cannot be in the denominator. So that is why I use the term rationalization. We are going to rationalize first of all this one. And you know that for rationalization, what do we do is 1 plus I whole to the power 13, and then the complex number denominator is 1 minus I to the power 7. Now in order to rationalize it, we will multiply the numerator as well as the denominator by the conjugate of the denominator, right? So the conjugate of the denominator, conjugate means just change the sign and write the number, is called as the conjugate, right? This term I am using very frequently, so please be very mindful. 1 plus I and then to the power 7, right? We are going to simplify. Now in the numerator we can see the bases are same, so their power can be simply added. It becomes 1 plus I to the power 20, because the power will be added because the bases are same. We can use the product law, right? Denominator, when we multiply these two, we can see their powers are same. That means we can have a common power for this both. That means inside the bracket we can have 1 minus I into 1 plus I whole to the power 7. Means if I write it here, 1 minus I times 1 plus I, and because the power of both the bases are same, therefore we can have a common power, right? Now the advantage of writing this way is now we can see that what is the format of this denominator, 1 minus I into 1 plus I. This is in the form of a minus b into a plus b. So we can see this as the factor of difference of a square. Therefore this can be written in the form of difference of a square, right? So when we write this in the form of difference of a square, it will be, numerator will be as it is, 1 plus I, and in fact this 20 also we can write this as 2 into 10. Is it okay? later on you will know that why we wrote it as 2 into 10. In the denominator it will become a square minus b square. A square means 1 square. 1 square means 1, and then minus, and then b square means I square. I square is as it is I square, and then to the power 7. Right? Now in the numerator, this square power I can apply for 1 plus I. That means we can use the expansion of a plus b whole square. So for 1a plus I to the power 2, we are going to apply the perfect square expansion, and the power 10 will remain as it is outside. So it is a plus b whole square. So it will be a square means 1 square plus 2ab, that is 2I, and then b square, that is I square, and then whole to the power 10 as it is. Come to the denominator. Now you know this is 1 minus I square value is minus 1. So that minus and this minus will make it plus 1, and this is 1 whole to the power 7. Is it okay? Now come to the numerator. Next, I square means minus 1, right? Minus 1. This is 1 plus 2I, and this I square will become minus 1 whole to the power 10 divided by 1 plus 1 is 2, 2 to the power 7. Now this minus 1 and this plus 1 is cancelled. Now we are left with 2I to the power 10. So we can write this as 2 to the power 10, and this I to the power 10 divided by 2 to the power 7. This 2 to the power 7 is cancelled. The power of this will reduce by 7, so it will become 3. Right? Next step, we can write this as 2 to the power 3 as it is. And this I to the power 10, we can write it as I to the power 8 into I to the power 2. We have split the power, right? And why we split the power like this is because in the previous exercise, I gave you the concept that if, since I is equal to root over negative 1, that means the square of I will become minus 1. And further if we square, then it becomes plus 1. That means I to the power square to the power 2. It means I to the power 4. So whenever the power of I will be 4 or multiple of 4, then the value will become equal to 1. And that is why we have split the power I to the power 10 as I to the power 8 into I to the power 2. Right? This is because I know that this will give you positive 1. Right? So this will give you 1, and this 1 into this 2 to the power 3. 2 to the power 3 is 8. Right? Times 1 multiplying 8 will remain same, and this I square will give you minus 1. So with this minus 1 you multiply this one, ultimately your complex number is minus 8. So on simplifying, this complicated complex number has come out as only minus 8. Has come out as only minus 8. So this is that complex number which we are supposed to write in the polar form. Is it okay? And in this complex number, you have only the real part, but the imaginary part is missing. So if we write this properly, then the actual complex number is negative 1 plus 0 times I. Why? Because the imaginary part is missing. That means definitely the coefficient of I is 0. And therefore, I can write the complex number as minus 8 plus 0I. Is this very clear? Now we are going to write this in the polar form. Clear? For this, we will first of all find out the modulus. That modulus R will be equal to negative 8 square plus 0 square root over, this will become 64 root over, this is equal to 8. So the modulus of this number is 8. Now we are going to find the amplitude, and I told you again, I am repeating, whenever we are calculating amplitude, theta cannot be calculated directly. We need to first of all find out the acute angle, and for that acute angle we need to know what is the location of our complex number. So let us come to this one. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant, right? Just as a reminder, I will give you the values of the amplitude in 4 different quadrants. Clear? So this is first quadrant. So here theta will be equal to alpha, right? This theta will be equal to pi minus alpha, and here third quadrant theta will be equal to alpha minus pi, and if it is in the fourth quadrant, then theta will be equal to minus alpha. Clear? We know that this is very important for us to remember. Now we are going to find the location of this complex number. The complex number is minus 8 and 0I. The minus 8 means it will be lying on the x-axis, right? That is, this is the complex number. This is the complex number. That means it will be taken in the second quadrant. So now we can find out the acute angle. So alpha is equal to tan inverse y 0 over minus 8, 0 over minus 8, which will be equal to tan inverse 0, right? Now tan at what angle? The value is 0. We know it is equal to, it is at equal to 0 degree angle only. Therefore alpha we got it as 0. Clear? Now therefore we can have the theta. This implies the theta will be equal to pi minus alpha, whereas pi is pi and alpha we have calculated is equal to 0. So this is 0 is equal to pi. Therefore theta is equal to pi. Now we can have the polar form. Therefore the polar form of the given complex number can be written as r. R is calculated as equal to 8. So 8 times, right, cos of pi plus sine I times sine of pi, and this is your final answer. Is this very clear? Now before I end this lesson, I will tell you sometime there is some question. There is one question where the question says to plot the complex number on the plane. On the plane, it's very simple to plot the complex number on the plane. No, it's like suppose your complex number is minus 8 and 0i, and as I told you, this is the real part, this is the imaginary part. The real part will be plotted along the x-axis, imaginary part will be plotted along the y-axis, right? So using the concept of plotting the complex number only, we are finding the location of the complex number, right? So when we are asked to plot it, we can first of all plot it along the x-axis, this value, and this will be plotted along y-axis. So the way normally we used to plot the given ordered pair, same way we can plot this complex number also on the plane. Is this okay? So just keep in mind that the real part will be plotted along the x-axis. If it is negative, then it will be on the left side of the origin. If the value of x is positive, then it will be plotted along right side of the origin. And then this is the imaginary part. If this is positive, then it will be plotted above the origin. And if this part is negative, then it will be plotted along in the downward direction. And this is how we can plot the complex number on the plane. Clear? So with this, we are ending the session. Thank you so much.